Jai Hind everyone. Myself Sandeep Yadav, Assistant Professor CS Department. In the series of lecture being delivered on DBMS, I am here to express my views on data abstraction. First, what is data? Data is a collection of raw facts, and after refining it, we get information. See, data is a collection of raw facts, and those raw facts are processed, and these processed facts are used in database. See, what is database? Database is a collection of interrelated data, and DBMS is a software which is used to process those data, to store those data, to disseminate information of those data. See, DBMS are made of complex data structures. As such, it is very difficult for a user to deal with DBMS. So, the details are hidden from the user, and this process is known as data abstraction. So, the very purpose of data abstraction is to hide the detail from the users. Now, there is a 3 level of data abstraction. Number 1, as you can see in the diagram, there are 3 levels of data abstraction. First is internal level, second is conceptual level, and topmost is view level. See, internal level decides how the data is to be stored, how much the memory has to be allocated, what are the various access methods that are going to be used to access the data. This is all about the physical organization of the data. Next level is the conceptual level or the logical level. This level decides what data is to be stored, what relation exists among the data. This level is defined by DBA. DBA is database administrator. His responsibility is to ensure the schema definition, to ensure the backup recovery. This conceptual level actually defines the logical schema of the database. Next level is view level. As you can see, there are different views here. This is the user view, and a user only get to see only certain portion of database. He is not able to see all portion of database, right? Why? Because a user is only interested to see only certain portion of database. Therefore, there are different views. For example, no student is interested in seeing the complete result of all the students in AKTU. He or she is interested in only seeing the result of himself or few of his friends. That's why it is not possible to have only one view. Therefore, we are having different view here. This view is also known as external view. Now, depending on users, there are multiple type of users of database. First user is naive user. A naive user is a user who has zero technical knowledge. These are the persons who don't have any technical knowledge and they use the ready-made applications. Second type of database users are the sophisticated users. These users are those who have certain degree of technical knowledge. They interact with the system by writing queries. Query is just seeking information from the system. So, a sophisticated user just write the query and interact with the system. Third type of user are specialized users. A specialized user is a category of sophisticated user who do not fit in traditional DBMS approach. Instead, he or she use complex database such as GIS, CAD, CAM, etc. Next category of user is application programmer. Application programmer is the person who writes the application program. Next, now we will define each level one by one. First is internal level. This level, as we know, describe how the data is to be stored in the storage devices, how the physical storage of data has to be there, how the data is to be recorded on disk. It can be arranged in file, pages, blocks, indexes, and ordering of records. We know file is a collection of records, and there are various pages also. We have to make use of index also to have the faster access. Now internal view is being described by the internal schema. Next level is the conceptual level or the logical level. This level decide what data is to be stored, what relationship exists among the data. To express relation among data, we can use various type of data models. We can use relational model such as ER diagram, where the relation among the data is being represented diagrammatically through ER diagrams, where there is a concept of entities. An entity is a real-time object that has a logical meaning or a physical meaning or a physical existence. For example, student database may consist of student and course detail, but user need not to be aware of the storage details. Now this level is defined by the database administrator. Database administrator define the logical view, what data is to be desired, what information is to be kept, which entity are to remain in the logical structure of database, and which are not to remain in the logical structure of the database. For example, consider a simple relation student. What information about the student is relevant, which we want in our relation. For example, we can include a student name, we can include his roll number, his father's name, date of birth, mother's name, contact number, and so on. So it depends on the DBA what detail he want to include depending on the requirement of the client side. Next level is external level or the view level. This level describe the only a portion of database that a end user want to see, or he or she is interested to see. Different user need different views of the database, therefore there are different views at this level. Each user want to see only a subset of database. He or she is not interested in seeing the entire database. Next, how we perform mapping in this. Mapping is basically sending the request by the user and getting the result from the all the three levels, that is mapping. There are two levels of mapping between the internal level and the conceptual level, and mapping between the view level and the logical level. So the entire purpose of mapping is to handle the request and the result. Next in this is the concept of data independence. Data independence basically means the ability to modify a schema at one level without affecting a schema definition at next higher level. Now that is the data independence. Now before understanding more about data independence, we must be clear with the concept of schema. Schema is just a logical grouping of database. There are various types of schema here. Physical schema is there, logical schema is there, and conceptual schema is there. Now the value of database keeps changing over duration of time. The value of database at a particular moment of time is known as instance. We need to preserve the instance or the snapshots of database, so that whenever we require to see old values, we can retrieve the old values from there. Now there are two types of data independence. First is physical data independence. Physical data independence is the ability to modify the physical schema without doing any modification at the conceptual level and the application program, that is the level above the physical level. Modification at this level are necessary to improve the performance. Modifications at internal level may be modification in the file structure. We can change the file structure, we can change the compression techniques, we can use LZ77 or 78 or any other image compression techniques, we can change the access methods, we can change the storage devices. So, modification in any of these will not lead to any change at the above level, that is the conceptual level or the application level. Next is logical data independence. Logical data independence means it is the capability to modify the conceptual schema without causing any change in the external level or the view level, that is the level about the physical, the level about the logical level. Modification is necessary whenever we want to make any change in the logical structure of the database. Well, the logical change in the structure of database is required on the side of DBA. A DBA is the only person who is required, who has the capability or who has the authorization to make logical structure in the structure of database. So, application program are heavily dependent on the logical structure of database. So, to change that, it is very difficult to make changes in logical structure. That is why the physical data independence is more easy to do as compared to the logical data independence. Now, let us discuss some more terms in data abstraction in database. First is metadata. Metadata is data about data. How many table we are having DBMS? So, we must have some structure where we get all these details. So, metadata is data about data, that is also known as data dictionary. Data such as table name, how many columns are there, what are the various data types is there, how many users are there who are having the privilege, what are the access methods, that is all these information are present in metadata. Consider the following example of a relation faculty. This relation is having the following attribute: employee name is there, address is there, mobile number is there, and subject is there. A row has been inserted here which consists of the following entries: Anuj Kumar Daily, mobile number and subject DBMS. So, metadata for the above table is: first is the name of the table, second the attributes, the column names which are employee name, address, mobile number, subject. Third is data type. The data type is varchar for variables and decimal for numerics. Access method. What are the various access methods which can be used? Either we can read or we can write. These are the access method. For doing any updation, we have to use write. Next is again data dictionary. We have already discussed. Data dictionary is the information repository which consists of metadata. It is same as we have used in the previous. It is all about metadata. Now, data warehouse. There are two types of information. One is informational database, which is day-to-day database. Second is historical database, the database of previous years which is no longer in use. So, data warehouse is a repository of historical information as well as the current informational. Suppose a company want a record of sales record of last 10 years. So, from where to get the information? To get that information, we need data warehouse. Data warehouse is a repository which stores database. So, to fetch data from warehouse, we need data mining. Data mining is basically finding the new patterns of knowledge from the warehouse. For that, we used various data mining algorithms such as classification, clustering is there, regression is there, and other things. Some more terms used here are a field. A field is a character or a group of characters which have the specific meaning. For example, the value of employee, name, address, mobile number, etc. are all the field. The name of the employee in previous field, that is Anuj is a field, Delhi is a field, mobile number is a field, the subject DBMS is also field. Sandeep is a field, Ghaziabad is a field, Da is a field, mobile number is a field. Now tuple or the record. A record is a collection of logical related field. It is a collection, for example, the collection of all the fields employee name, address, mobile number and subject. So, in here we are having two rows, tuples or records in our relation. We have already discussed what is schema. Schema is the logical structure of the database. It is a description of particular collection of data using a data model. Schema is the overall design of the database. It is the skeleton structure that represents the logical view of entire database. There are two types of schema. One is physical database schema, another is logical database schema. Physical database schema is used at physical level, as well, whereas the logical database schema is used at the logical level. Instance is value of database at a particular moment of time. Since the value keep changing over a duration of time, so we need to preserve the instance or the snapshot of the database. Now database, there are different type of database users, naive users are there, application program are there, sophisticated users are there and specialized users are there. All the users are having their different functions. Next is the role of DBA. DBA is the person who has the central command over database. He is the person who overall supervises the database. So DBA has the following roles. First, he defines the schema. He defines the logical schema of the database. Second, he decides how the data is to be represented in the database system. That is, what data storage structure will be used, what access method will be used. He defines all the security mechanism and the integrity constraints. Integrity constraint may be the constraint related to the primary key or the constraint related to the foreign key. Next, he the person who grants the authorization to the user for database access. What the user can access, who can access the database, what privilege he or she is having. That is also the function of DBA. He is the person who is liaising with the users. He provides the necessary data to the user. He is the person who is responsible for backup and recovery. That is a very important role of DBA. In case of a failure or catastrophic event resulting in the loss of database, this function of DBA is very much required. DBA also assists the application programmer to develop the application program. A DBA also monitors the performance so that the physical or logical data independence is achieved properly. DBA is also responsible for the view definition. He defines the view for different persons. Since we cannot allow all the persons to access the database directly. Instead, we provide view. Through view, a user can view the database that is required for him. Now, next is the concept of key in DBMS. Key is an attribute or a set of attributes that is used to identify a data in database. Key is generally used for the unique identification of rows or tuples in tables. Key allows us to find the relation between two different tables. Different types of keys are there. Super key is there, candidate key is there, primary key is there, alternate key is there, the foreign key is there. Each key has its own function. First key is super key. Super key is a attribute or set of attribute which allows for unique identification purpose. Consider the following example. Here the table is having the following set of attributes. Enrollment number is there, roll number is there, branch is there, semester is there, SPI, student progress index is there, name is there, student name of course, and BL means backlog. So we have to see how many keys are there, super keys are there, which are able to uniquely identify the student. See, student roll enrollment number is unique one. No two student will have the same enrollment number. So one of the super key is enrollment number. Now we are saying second attribute is roll number. Roll number alone here in this case is not able to define uniquely. So we club it together with branch. Now branch is again redundant. It is being repeated for several students and semester. Third is semester. Now if we combine together all these three, say roll number 101 is in C branch also and CI branch also. But if we combine it with branch and semester, then these three together will uniquely identify the student. Third, if we make a combination of SPI, student name and BL, it will not be a unique one because the same student may be present. Same student may be having same name as well as the same API and same number of backlog. For example, there may be two Raju who are having same SPI and same backlog. So it is not possible for us to identify that. Next is candidate key. Candidate key is a subset of super key. It is a minimal super key such that no subset of a candidate key will uniquely identify. For example, see roll number is there, enrollment number is there. Suppose roll number is also unique and enrollment number is there, then the candidate key is enrollment number is there, then roll number, branch name and semester is also a candidate key. Candidate key is a minimal super key, that is every candidate key is a super key, but not every super key is a candidate key. Means that subset of a candidate key does not uniquely identify. Next is the primary key. Suppose we are having two candidate key in a relation or even a single candidate key in a relation. Suppose we have two candidate key, one is roll number, other is enrollment number. Then the candidate key that is selected by database designer for unique identification purpose is known as primary key. Suppose we select roll number as a primary key, then we select roll number for unique identification purpose, then it becomes a primary key. And alternate key is the candidate key that is not being selected by the database designer for unique identification purpose. Consider an example whereby there are two candidate key, roll number and enrollment number. Suppose roll number is selected by database designer for unique identification purpose, then it becomes the primary key, and the other key, enrollment number, that is not selected by database designer, becomes the alternate key. Next key is foreign key. A foreign key is a key whose value is being imported from the primary key of another relation. For example, we have two relations, one is employee relation, other is department relation. In department relation, there is a primary key department number which is having certain values, let us say 10, 20, 30. And suppose there is employee table which also consists this same attribute department number. This department number fetches its value from the primary key of department table, that is 10, 20, 30 value. Then this attribute becomes the foreign key in the employee table. So a foreign key is a key which depend on the primary key of the another table. That is, the value of a foreign key is equal to the value of primary key, or it may be entirely null. Next, there may be another variety also, that is secondary key. For example, student name is not unique. Two students may have same name. Such type of key is known as secondary key. Beside that, we can have also new variety of key, that is unique key. A unique key is having unique attributes that help in unique identification purpose, but its value may be null. The next is candidate key. Again, we have discussed the candidate key, but there is one more important concept regarding candidate key, that the primary key cannot have null value. This rule is known as entity integrity rule. I repeat, primary key cannot have null value. This rule is known as entity integrity rule. Second is referential integrity rule. This rule is concerned with foreign keys, and it states that the value of a foreign key is equal to the value of primary key, or it may be null. Thank you everyone.